Hello everyone, welcome to our presentation on chatbots from rule-based systems to emotion-aware AI assistant. We are a group of three people. My name is Tribhuvana Avvaru and my friends are Neha, Mohana and Sreevardhan Veduri. Today, we will take you through the fascinating evaluation of chatbots, how they have progressed from simple rule-based programs to intelligent, emotionally responsive systems powered by NLP and large language models. Let's begin with the basics. What exactly is a chatbot? A chatbot is an AI system designed to simulate human conversation either through text or voice. It allows users to communicate naturally with machines without needing to understand programming languages. Chatbots are everywhere today, from customer service platforms, online stores, virtual tutors, and even healthcare support systems. They help automate repetitive tasks and provide instant responses to user inquiries. The field of natural language processing or NLP plays a crucial role in this. NLP equips chatbots with the ability to understand the meaning, emotion, context behind human speech. In this presentation, we'll discuss how chatbots evolved, the key NLP techniques they use, the role of deep learning and the large language models, and how emotion awareness has made them more human-like. Let's discuss historical overview of chatbots. It all started in 1966 with ELIZA, developed by Joseph Weizenbaum at MIT. ELIZA mimicked a psychotherapist by reflecting users' sentences back at them. For example, if you said, I feel sad, it would respond, Why do you feel sad? There was no true understanding, just pattern matching using scripts. In 1972, Perry was created to simulate a patient with paranoid schizophrenia. While slightly more complex, it still relied on rules and predefined responses. Fast forward to the 1990s and 2000s. Chatbots like Alice used keyword based retrieval, and Smarter Child began appearing on messaging platforms. These were still limited but more interactive. The real breakthrough came with deep learning. Models like sequence to sequence introduce the idea of training chatbots to generate replies from data rather than depending on hand coded rules. The latest milestone came from transformer based models, especially GPT, T5, GPT, which can understand context, tone, and emotion. These systems made chatbots more intelligent, responsive, and lifelike than ever before. NLP techniques used in chatbots. Now that we understand the evolution, let's explore the key NLP techniques that make chatbots possible. The first step is text pre-processing, which involves cleaning the input text, removing stop words, punctuation, and converting it into a suitable form of analysis. Next comes tokenization, where sentences are broken down into smaller units or tokens which help the system analyze meaning. Intent recognition. It is one of the most important parts. It determines what the user wants, whether it's booking a flight, checking the weather, or canceling an order. Then there's entity recognition, which identifies specific names, dates, places, or products mentioned. Context tracking. It will allow the chatbot to remember what has already been said, enabling natural multi-turn conversations. Finally, response generation. It forms the output, which can either be selected from pre-written responses or generated dynamically using a model. Together, these techniques allow chatbots to transform human input into structured data and then back into natural conversational language. Now let's discuss dialogue management. Dialogue management controls how a chatbot decides what to say next. It consists of two parts: state tracking and policy learning. State tracking. State tracking keeps a record of the conversation so that the context is maintained. This helps avoid repetitive or irrelevant responses. Policy of learning. Policy learning uses that context to decide on the next best action. That is, whether to ask a question, give an answer, or transfer the conversation to a human. Early chatbots relied on manually written flowcharts, but modern systems use reinforcement learning, where the bot learns from the feedback to improve its responses. Effective dialogue management ensures that the chatbot's responses remain coherent, logical, and contextually appropriate, making the experience smoother for user. Now I'm going to hand over the presentation to my friend Neha Mohana. She's going to continue. Architectures of chatbots. There are three main types of chatbot architectures. Rule-based chatbots operate entirely on first conditions and pattern matching. They are easy to build but very limited. Retrieval-based chatbots rely on a database of pre-written responses. They use similarity scoring, for example, cosine similarity or TF-IDF, to find the most relevant answer. Generative chatbots go a step further by creating new, original sentences using machine learning models. Many modern systems are hybrid, combining the accuracy of retrieval based methods with the creative of generative models. This balance ensures both safety, avoiding irrelevant or offensive replies, and natural conversational flow. Deep learning and LLMs for chatbots. Deep learning, especially through large language models, has completely changed how chatbots function. Models like GPT, T5, and DLO GPT are trained on massive datasets containing text from books, articles, and conversations. They learn grammar, semantics, and even tone. These models are based on transformer architecture, which uses a mechanism called self attention. This allows the system to focus on relevant parts of input text and maintain context over long conversations. With LLMs, chatbots can now handle multi turn dialogues, generate contextually accurate responses, and even perform emotion detection or summarization, all within a single framework. The generalization power of these models allows them to adapt quickly to different domains, from customer support to education, without retraining from scratch. In short, LLMs have made chatbots smarter, more flexible, and capable of human like interaction. Ethical and social implications of chatbots. As chatbots become emotionally intelligent and deeply embedded in our lives, ethical and social implications can't be ignored. One major issue is bias or fairness. Chatbots trained on internet data can unintentionally learn stereotypes about gender, race, or culture. Imagine a hiring chatbot showing preferences for certain names or accents. That's an ethical failure. Another key area is data privacy. Chatbots often store sensitive personal information such as names, health conditions, or emotions. Developers must follow strict data protection standards and anonymize user data to maintain trust. Transparency is also critical. Users should always know when they are interacting with a bot and not a human. This avoids confusion and keeps expectations realistic. On the emotional side, dependency is a growing concern. Emotion aware chatbots like Replica or Character.ai can form emotional bonds with users, which raises questions about over reliance or loneliness reinforcement. Lastly, responsible AI means balancing empathy with integrity. Chatbots should comfort users, not manipulate them or spread misinformation. Ethical design ensures chatbots serve humanity positively, being helpful, fair, and safe without crossing ethical lines. Emotion aware chatbots. The next major step in chatbot evolution is emotional intelligence. Emotion aware chatbots go beyond understanding words, they detect the feelings behind them by analyzing emotional tone. These chatbots can sense when a user is happy, angry, or upset and adjust their responses accordingly. For example, if a user says, I am feeling really stressed, the bot might reply empathetically, I'm sorry to hear that. Maybe taking a short break would help.
Emotion aware systems rely on sentiment analysis and emotional classification using data sets like Go emotions and models such as Distal Row BRT A emotion. These systems are particularly valuable in mental health, education, and customer support, where empathy and understanding are crucial. NLP tools and frameworks for chatbots content. Developers today have access to several tools and frameworks that simplify chatbot development. NLTK and SPACY are popular for text preprocessing and tokenization. RASA provides a complete pipeline for intent detection, entity recognition, and dialogue management. All are open source. Hugging Face Transformers allows developers to use pre-trained conversational models like Dialog GPT and BERT with just a few lines of code. And Gradio helps quickly build web interfaces so users can chat directly with the bot online. Together, these frameworks have made it easier than ever to build powerful NLP based chatbot systems, even without deep programming expertise. Now, my friend Sai Sreevardhan Veduri will continue the presentation.
Now we'll see about challenges and limitations. Despite major advances, chatbot technology still faces many challenges. Sarcasm and irony are very hard for models to detect accurately. For instance, oh great, my phone died again. Sounds positive, but expresses frustration. Context drift is another problem. During long conversations, models often lose track of earlier topics. Bias in training data is also a serious issue. Chatbots can unintentionally reflect social or cultural prejudices. Privacy is a concern as well. Chatbots often handle sensitive user data. Lastly, large models require high computational resources, making real time deployment expensive. Addressing these challenges requires careful dataset design, model optimization, and transparent AI governance. Now we'll see the real world applications. Chatbots are now deeply integrated into our daily lives across various industries. In customer service, they respond instantly to user queries, improving satisfaction and efficiency. In healthcare, they assist patients by offering reminders, tracking symptoms, or providing mental health support. In education, chatbots act as virtual tutors, helping students revise topics or practice languages. In e commerce, they recommend products, handle orders, and manage returns. And in entertainment, they engage users in conversation for fun and companionship. These applications highlight the versatility of chatbots and their role in automating communication while maintaining a human touch. Now we'll see the future directions. Looking to the future, several exciting developments are on the horizon. We'll see multimodal chatbots that combine text, speech, and facial recognition to read user emotions more accurately. Personalized chatbots will adapt their tone, vocabulary, and even humor based on the user's personality and past interactions. Cross-lingual chatbots will handle multiple languages seamlessly, breaking down communication barriers globally. At the same time, the focus will shift toward ethical AI, ensuring fairness, transparency, and respect for privacy. Finally, explainable AI will allow chatbots to justify their decisions and responses, making them more trustworthy and accountable. The future is about creating systems that don't just talk, but genuinely understand and connect with humans. Now we go for the final conclusion. To conclude, chatbots have come a long way, from ELIZA's rule based replies to GPT powered emotion aware assistance. NLP has been the driving force behind this transformation, empowering missions to understand intent, context, and emotion. Deep learning and large language models have turned chatbots into intelligent, empathetic communicators. The next frontier lies in combining emotional awareness, personalization, and ethics to build systems that are not only smart but also sensitive and humane. The emotion aware and context sensitive chatbots are human computer interaction, creating systems that are both intelligent and empathetic. Thank you.